Okay, on number 1, remember that we're talking about 95%, so it's between this area and this area, so the answer is going to be B. And then on number 2, the answer choice is D. Remember that C is if it's talking about the median, B is talking about the mode, and A is talking about how do you find the standard deviations. On number 3, if you were to draw a straight line down the middle, your normal curve, the average is going to be about 100 because it's right in the middle. And now remember, when we talk about the standard deviation, in order to see the first standard deviation, you go where the line kind of curves out, flattens out, draw a straight line down, and you notice it's about at 115, so the difference there is about 15. That's why C would be the answer on that as well. On number 5, if you'll look, it's asking what percent is below, it'd be less than 10. Well, if you notice between these two right here, this is a 95% confidence interval, or that's 95%. Well, that means there's 5% left. That means there's 2.5 on this side. That means it's 2.5 on this side. Therefore, 2.5% would be your answer. So the answer choice is E. Okay, on number 6, a child's 40 inches tall. It's in the top 10%. Well, we know that they're in the top 10%. We want to know what is the standard deviation. Well, in looking for that, let's look at all of the information that we have. I know that they've given us 10%, so that means I can find the z-score that corresponds to the 90%, which is 1.28. That's this right here. I then use that in my equation. I plug in all my information, and the only thing I have to do is just swap these two. And when you do it, you get the standard deviation is 40 minus 38 divided by 1.28, and that turns out to be a standard deviation of 1.56, which happens to be answer choice E. Okay, on number 7, they gave us the standard deviation, which is 2.5. They gave us the average, and they gave us the standard score. So they want to know what is the height of this adult male. Well, if we take that and we multiply both sides by 2.5, you end up getting 0.75 is equal to x minus 69. All right, remember, those two canceled out. Then if you add the 69 to both sides, you end up getting 69.75, and that is how tall the male is. So therefore, the answer choice is D. Now, I know number 8 was a little controversial when we talked about it, but if you look at this, I know that A and G are my minimum and maximum, so that's why I marked out E. That is definitely not the answer, because we're looking for something that's not part of the 5-number summary. Now, if you look at E, E is going to be our median. Remember, the median does not waver when it talks about when we're dealing with skewed data. So therefore, since E was part of the 5-number summary, I marked out C and I marked out A. That left B and D. Well, they both have F, so I know F is not part of the 5-number summary, so I don't have to worry about that. But I do want to look at these C, and I want to look at B. All right, you've got to consider that whichever one's going to be Q1 is got to be about 25% of the area, and we know that that would not be about 25% of the area just based on physical nature and what we know of like a normal distribution. So we know that would not contain 25% of the area, or at least 0.25. So that's why B in this case, in my best opinion, would be the answer. On number 9, the answer choice is E. If you think about it, what can be said about the percentage of observations fall within 2 standard deviations? Well, 95% always falls within 2 standard deviations, regardless of the normal distribution. So because they have identical means, they're going to have, the percentages are going to be identical. On number 10, it's asking you how can you tell who did better on the exam. Well, it gives you the information to find the z-scores of both. And what I highlighted in green is Jane's score from 1994, and she has a 0.27 standard deviation. And Colleen had a 0.2. Therefore, Jane did better on the test. Therefore, her answer choice would be C. On number 11, what is the interpretation of a z-score of -3? Well, that means you're 3 standard deviations below the average. Therefore, the answer choice is D. On number 12, it says, which of the following is not a characteristic of normal distribution? Well, the key word is not. The median and the mean is always equal, so it's not that one. The mean of the distribution can be positive, negative, or 0. That is true. The averages can be any of those, because any number can be 0, or any average can be 0. Any average can be, you can have a negative average or a positive average. The distribution should be symmetrical, as we've discussed, and if you have 3 standard deviations, again, the empirical rule says it's 99.7%, and so yeah, almost the entire population is underneath or within 3 standard deviations. That means only 0.3 is not within that. So the only possible answer is the standard deviation is always 1. It's not always 1. Your standard deviation can be any number. Remember, it's the distance from the mean. So the answer choice is A. Okay, on number 13, it's basically saying how much would an adult male Asian elephant have to weigh in order to have the same standard weight as an African elephant. Well, that means we know that the z-scores are going to be the same. That's why I've done this. So that's why they both have the same z-score. Now watch. I take the weight of the elephant, subtract it from the average, divide it by the standard deviation, and I get a z-score of 1.5 for the African elephant. Since the Asian elephant has to have the same z-score, I plug in the z-score, I plug in the average, and I plug in the standard deviation, and then I'm going to look for the weight. I then multiply both sides by 680, so 680 times 1.5 is 1,020. I then add 7,200 to both sides, and the weight of an Asian elephant that's going to be with the same standard deviation would have to be 8,220 pounds. Okay, number 14, it's asking for what percent, so we're looking for a p-value, and would hold less than 73.6 tons. And then on part B, it says, based on your answer in part A, what do you think that the loading mechanism is out of adjustment and is underfilling? Or would you think that it is out of adjustment? All right, so we're going to look at both of those. Okay, if we look at the information given, we notice that what percent would hold less than 73.6, so that's an X. So I basically go X minus my mu divided by standard deviation. That gives me a z-score of -3. Now if you think about it, down here, that's going to be about right here. So if you have a z-score of -3, that means if you look up the z-score of -3, that's 0.0013, or basically 0.13% of the time. Now if you did it using the empirical rule, you'd get 0.15%. Nonetheless, both of those are extremely small. So the fact that it even happened, you would think that the loading mechanism is out of adjustment, because it would rarely even happen. And therefore you might suggest that you recalibrate or at least look at recalibrating the automatic loader. Okay, number 15A, it asks you to draw or sketch a normal curve. Well, notice I put the mean in the middle. That's 219. I added 38 each time, and then I subtracted 38 each time in order to get my normal curve with all my data. Okay, in part B, it says use the 68, 95, 99.7 rule to estimate the proportion between 143 and 257. Well, if you notice, we're using the 68% and only half of the 95%. So the 68 plus the 13.5 gives you 81.5%, and that goes right here. And the way you would state that if you were writing a complete sentence is estimate the proportion of cities. So 81.5% of the cities would have between 143 and 257 days of sunny or partly sunny conditions. Now in question C, it says you want to move to a city that's in the top 40%. Therefore, if you're looking at the top 40%, that means you have to look at the 60% that are at or below that z-score. On C, you would then find the p-value, convert it to a z-score of 0.25, and you'd place it in your formula right here. Now, when you solve for the number of days, again, you would multiply both sides by 38, then add the 219. What you end up getting is your days would be around 228.5, so around approximately 229 days. So you would need to find a city with at least 229 sunny or partly sunny days to fit your requirement. Now on the last question, D, it says Texas or El Paso, Texas has 307 days out of the year. Is this number of days unusual compared to the other U.S. cities? Well, notice what I've done. I basically took the 307, subtracted the average and divided by standard deviation. They have a z-score of 2.32. I then converted it to a p-value of 0.9898. Now, notice that basically says, hey, this is the 98%. But you know what? In this case, how much have more than that? Well, if we subtract that from 1, that means 0.0102. That's this right here, or 1.02% of the U.S. cities have a temperature, or sorry, have over this amount, over 307 days that are sunny or partly sunny. So the fact that El Paso has is at that mark of 1.2% or above 1%, I'd say it would be pretty rare that a U.S. city would have that amount of sunny days. In other words, not every city is going to have that much sunny weather.